So, greetings everyone. Welcome on today's ConSteel webinar, which will be about the parametric modeling with ConSteel programming interface through user-defined input dialogues. My name is Roland Doka. I'm working as a support engineer and I am going to be your host today. Let me summarize the summer webinar series of this year. So far we had a previous webinar about the imperfection method, which was about the background of the Eurocode 3 imperfection method. It was about the application issues and supplementary tools, classification of different buckling modes and direction calculation, and also the application possibilities in ConSteel 12. This webinar has already been recorded and it is available on our YouTube channel. Also, we are going to have one more webinar in this summer webinar series, which will be about the design of concrete structures in ConSteel. The date of this webinar will be next week's Thursday. Some practical notes about GoToMeeting. You can hide the control panel with the red arrow button, and also you can ask questions in the questions panel, and I will answer those questions at the end of the webinar. The content of today's webinar will be basically about the new functions of ConSteel programming interface in ConSteel 12. First, I will summarize the user experience improvements in ConSteel 12. This is basically the automatic code check and also a debug function for the programming interface. I will then talk about the new tool for the data input into the programming interface, which are basically the dynamic dialogues, and also I will show you what are the new possibilities regarding to modeling in ConSteel 12 with the programming interface. And of course I will demonstrate on a live demo these new functions. So there were some improvements in the user experience in ConSteel 12. Basically, automatic code check was implemented into the software, which is used to eliminate mistakes before running the script. So right when you are typing the script, ConSteel will throw you error messages and warnings, so you can avoid mistypings and you can follow correctly the syntax rules of the programming interface. Also, there is another troubleshooting tool, the Debug Function, which can eliminate misbehaviors of your code, and you can follow up on the variables of your code during the use of this debug function, and you can use this debug function for a better understanding of your code. The main topic of today's webinar is the new tool for the data input. Data input was maybe a bit hard until ConSteel 12. Every time you wanted to change something in your code, you had to dig into the code. So you had to open this ConSteel programming interface editor and retype the values of the variables. Now you can create your custom dialogues where you can place different controls such as edit boxes, drop-down menus, checkboxes, and with these tools you are able to modify your script without the need of digging into your code. And I will show you on the live demo how this function works. The other improvements was the expansion of the modeling possibilities with new modeling functions such as select, move, copy, rotate, and mirror commands. All of these commands can be found on our wiki page, which I will show you. And yeah, let me tell you about our ways of the development with ConSteel programming interface. In ConSteel 12, we are finished with the modeling functions. One main function is missing right now, the load and mass combination creation and generation through csPI, and this will be implemented in the next version. But modeling functions are a complete we have a complete solution in the csPI. The next step will be the analysis and design functions to make them available in csPI. So basically, in the next versions of ConSteel, you will be able to control analysis and design functions also through csPI. You will be able to get analysis results, store analysis results, and export analysis results directly from csPI. And this is the short term. These are our short term plans. And on the longer term, the optimization is the next goal which we want to achieve. So basically, you will be able to create, analyze, design, and optimize your structure, and all this through csPI. Let me introduce you some useful information. We have a website, consteelsoftware.com. Here you can download our software, and also you can ask a trial license. We have different channels where you can follow us. For example, we have a Facebook page, we have a blog, and we have our YouTube channel where you can subscribe, and where we regularly posting videos and posts about frequently asked questions, customer projects, and tips and tricks. Also, we have an essential tool for ConSteel programming interface, wiki.consteelsoftware.com. At this page, all of the comments which are available for the programming interface are described in details with copy-paste sample codes, but I will show you this later. We have two email addresses where you can contact us. The first is the info@consteelsoftware.com. If you have sales-related questions, you can send an email to this email address. Or if you have program-related questions or support requests, you can contact us at support@consteel.atlassian.net, where one of our support colleagues will be glad to help you. Also feel free to contact us on phone. Okay, and now I want to turn on to the live demonstration. I will open up a new model. And first I'm going to quickly show you how the automatic code check works in ConSteel 12. So I will open up the csPI editor, and this automatic code check continuously running in the background and checking your code, and if you make a mistake, it will automatically note you that something is not okay with your code. So for example, if I try to create a member, with some mistakes in the code, ConSteel will automatically give you an error message. For example, right now it says that we have an error, not allowed object type is used, structural member, and as I can see, I made a mistyping. So I left the C, and if I type it, the error message is refreshed, and now it tells us that the section cannot be found. This section, which I wanted to use for the member, cannot be found, so I have to load this section. Okay, and as you can see, we have one more error message to handle, which right now says that currently a zero-length member would be generated if I would run the code, and this is because the start point and the end point coordinates are the same. So if I erase this mistake, all of the error messages are gone, and as you can see, my member is created. So this is how automatic code check works. It continuously running in the background and checking your code. Okay? The next thing I want to show you is the debug function in ConSteel 12, for which I brought you a script which can be found on our wiki page. Basically, this script will generate us a frame, and I will use this to show you this debug function. So when you open up the csPI editor, you will see that there are some changes in ConSteel 12. First, on this side, you have a watch window function, watch window panel, which is by default it is empty, but it will be filled up when we are using the debug function. The debug functions can be accessed with this panel here, and basically what debug does, when you use this function, you can stop at any line in your code, and you can jump from line to line and investigate your code. What are the content of each variable, and yeah, that is what you can do with it. So how you can stop your code at a desired place? First, you have to place a debug point in any of your rows. So for example, if I place a debug point at the 5th row, I can do it by clicking on this button, the Add Debug Point button. And as you can see, the 5th line is highlighted with this white circle. This means that we have a debug point placed at this line. I will place another debug point, for example, in this row at the beginning of a for cycle. Okay, the next button is dedicated for the deletion of debug points, and if you click it, it will basically delete all of your placed debug points. And the third function is the Turn Debug Function On button, and let's click on this button. And as you can see, what happened right now, the code started to run, and it stopped at the 5th line. The line where the program stopped is highlighted with this transparent gray color, and also we have S equals question mark sign. What it means that currently in this line the definition of the value for the S variable happens, and if I jump one row with this go to the next row button, you will see that value is assigned for the S variable, and as you can see, this S variable is listed in the watch window. From now I can decide that I want to jump for the next row, or I want to jump to the next debug point, or if I want to release the code and run till the end. Let's say that we want to go to the next row of the code where another variable definition happens, the ch variable. As you can see, if I jump one more row, it says that the definition of the value took place, and the value of it is 4,000. One more function which is implemented in ConSteel 12, if you move your cursor above a variable, a pop-up panel will be shown, and it will show the exact value of the variable, of each variable. Okay, and if I go from row to row in my code, I will reach a mathematical operation here, where all of the variables which are used in this mathematical operation are listed here. And as you can see, currently the BL variable will get a value based on these other variables. And if I jump one more row, all of the variables which were used above my line are listed in the watch window. Okay, so let's say we want to jump to our next debug point, which is currently at the beginning of the for cycle. And as you can see, this is the beginning of the for cycle, where we have an n variable, which is the running parameter of the for cycle. Currently, it does not have a value. It will get its 0 value here when we will step a line forward, and the end parameter of the for cycle is Pn minus 1. So basically value is 3. So the for cycle will repeat itself 3 times, and we can follow this behavior with the debug function. So let's say I want to jump to the next row. As you can see, now the value of the n variable is 0, the Pn is 4, so we are in the for cycle, and in the next row we are reaching an if statement where we have on the left side we have this value, the n multiplied with the PD value, which will currently give us a 0 value, and if this value, if the multiplication of these two variables is less than the BL variable, we will initiate the if command, and the ConSteel programming interface will perform the code which is inside the if statement. So because this statement is true, the content of the if statement will be performed, and as you can see, we are stepped inside to the if statement. And we can jump from row to row, and when we reach the end of a for cycle, we will jump back to the beginning. The n running parameter is incremented by 1. Currently it is with the value of 1. The end parameter is Pn minus 1, so it's 3. So we will repeat the for cycle again. And this will continue until the running parameter will exceed the end parameter of the for cycle, and we can follow our code by this method. And if there are some problems with the behavior of your code, what you have written, you can always do this to examine that what is your code doing in the background. So we have finished our for cycle. We are continuing with the next steps of our code, and let's say I want to release my code and I want to run it till the end, and if I click this button, the code will be performed as a whole and our frame is created. So this is how you can use the debug function. It is a very useful tool if you have misbehaviors in your code and you don't know what the reason of this misbehavior. You can always do this debug function and go from row to row in your code, and it can help you to understand of your code. Okay, and let me show you quickly the new modeling functions in csPI, for which I'm again going to open up a new ConSteel. And while it opens up, I will show you the wiki page. So here at our wiki page, you can find all of the available csPI commands and descriptions, and also the new modeling commands are uploaded to this wiki page, so you will find the select, the move, copy, rotate and mirroring functions described in details. So for example, if I go to the, for example, rotate function, you can check the complete description of the command, and also you will find a copy-paste sample code which you can use and paste it into your ConSteel, and you can test the command. But right now I will load an existing csPI script which I have prepared. So in this model I will create some members. Just an example, 2 columns and 1 plate will be created, and I will use these to show you how these selections, rotations can be used. So first we have a bunch of selection commands. We have a pretty basic select all command. What this function will do, it will select all of the members, supports, any object what is represented in your modeling area will be selected, and these selected members can be used for later modeling commands such as move, copy, rotate and mirroring commands. But we have more sophisticated selection commands. For example, you can select individual members or more members by the definition of their IDs. So select by ID will select only those members which are defined with their IDs. We also have another command, the select by type, for example, select by type structural member selection, which will basically select all of those objects which are defined with a certain type. So for example, right now, if I type structural member for the selection and I rerun the code, only the structural members will be selected, as you can see, and only these can be modified with later modeling functions in your code. And also we have one more interesting selection command which I want to show you, which is the select by user command. What it does, it will throw up a dialog for you where you can decide that what are those members which you want to select, but in the modeling area. So this is the dialog which you will get. It will have a text which will tell you that please select objects, and also it will give you a select button. So if I click on this select button, I can select in the modeling area that which are those members which I want to select, and if I click a right click with my mouse, ConSteel will select these objects and it will store, so you can modify these later with further modeling functions. So it is basically a kind of a dynamic dialog. Okay. So these were the selection commands in ConSteel 12. I will use for the further modeling function the most basic selection command, the select all command, just to show you that how copy, move, rotate and mirroring commands works. So basically we can decide that all of these commands works pretty much the same. So I will show you the copy selected command only. So for example, this copy selected command works as I will show you in a moment. Every of these modeling function needs as a prerequisite command the selection command. So you have to select members which you want to use for these commands, and add the first 3 parameters, you have to define the start point of the copy vector. So, for example, right now we will use the 0, 0, 0 value as the first point of the start point of the vector, which will be used to copy the selected members. The next three parameters are the endpoint of this vector, and we have a bunch of optional parameters which are not necessary to be defined, but these parameters are basically those parameters which can be found on the copy dialog. So for example, the copy equals 1 currently means that the number of copies will be 1. I can raise it, for example 3, and it should be the same if I would use the number 3 here. We can decide if you want to copy structural members. If it is defined with a 1 value, it will copy. If it is defined with 0 value, it won't copy. We can say that we want to copy the loads which are placed on these members. Also, we can copy the supports, and we can join the points if we want to. So these settings are the same that you can find in the basic ConSteel move and copy dialog. Okay, and if I run the code with the select all function, what I'm expecting to see that ConSteel will copy the selected members 3 times with the specified parameters. But basically, rotate, mirror commands are works just the same like this copy command. Okay, as the next demonstration, I want to show you how the user input dialogues can be used and how they are working. So I will close this ConSteel, and I will quickly show you just what are the possibilities with these functions. First, on a pre-created script, and after that I'm going to show you how you can create these user-defined dialogues. So I brought you a script, and if I run this script, the user who is running the script will receive a dialogue. This is a completely custom dialogue, so I have placed these controls myself on this dialogue. So I can decide here if I want to delete previously placed structures or not. Right now I don't have anything in the model, so I cannot delete anything, but if I would have anything, I could, for example, copy it. If I would check this checkbox, I could mirror it, so I can place any kind of modeling functions here. And also I have created a drop-down menu from where I can choose that what kind of structure do I want to create right now. Let's say I want to create a sort of a block structure, and if I choose this from the drop-down menu and click OK, I will receive another dialog which I have created myself, where some decisions have to be defined by the user who is using the script. Currently, these questions are that will the user have, do the user have a block, a pre-created block in the model or not? So is this a first block which is created, or it will connect to an existing one? So for example, if I would have a connecting block at the -x side of the current block to be generated, I would create yes, but because this is the first one, I don't have to do anything on this dialog. And if I click on the OK button, I will receive my next dialog, where I can select that what kind of material grade do I want to use to generate my structure. Let's say I want to use S275 value. What should be the section of the beams? I have created a small drop-down menu where I can choose from IPE sections. Right now, let's say I want to use IPE 330 sections, and also I can select what should be the sections for the columns, and I have some preloaded sections which can be chosen. Let's say it is the 360. The dialog also asks that do I want to place bracing members on this block or not. If I click OK, the program will generate bracings also. We can define that what should be the height of this story, the height of this block basically. Let's say it will be 3000 millimeters. We can define the span both in X direction and also in Y direction. We can select the insertion point of the placement of the block. So if I click on the select button, I can tell that I want to place my first block with a starting point of this. And as you can see, the coordinates are loaded into this edit box here. Also, I can choose that do I want to place supports on the columns or not. Let's say I want them. And I can choose that what kind of supports do I want to place. Let's say I want to place a fixed support. Okay, and if I click on the OK button, the program, this is the last dialog, the program will ask that what should be the section of the bracing system. Let's say it should be a round bar with the 20 millimeters diameter, and the program will ask that on which side do I want to apply this bracing system. Let's say, for example, I want to apply on the minus X side and, for example, on the minus Y side. And if I click on the OK button, the program will generate for me this block. And if I rerun the code again, and for example I choose the block again, I can simply add another block to this. But right now I have a connecting block for the block which I want to create. So let's say on the minus Y side we have a connecting block, because here I want to place my next block. Again, I have to set the parameters which I want to use for this current block. I will select an insertion point, and I will also create a support, and I want to apply on these two sides the bracing system. And if I click OK, a block will be added to this existing as the existing structure, and I can repeat it as many times as I want to. So basically this is just a small example of how you can use the dialogues, the user-defined dialogues in ConSteel. But we have other functions which we can use. So for example, if at the first dialog I would choose that I want to create a load transfer surface for my structure, I would choose that from the drop-down menu. And on the next dialog I can choose that where I want to create a load transfer surface for my structure. So I simply click on those points which are the corner points of this load transfer surface, and as you can see, ConSteel has added this load transfer surface into my model. Okay, but we have some other functions which I have placed, but I could choose any kind of functions to place on these dialogues. But let's say I want to copy my structure, so I can define that which should be the start point of the copy and what should be the end point of the copy. And if I click on the OK button, I have to define that what are those objects which I want to copy. So I select currently, for example, all of the members, and if I click right mouse button, ConSteel will load it into this edit box. And if I click OK, we can copy these existing members into the model. Okay, but let's say next I want to create a frame, and also we can define the span of the frame, height of the columns, height of the top height of the structure, and distance between the purlins. So I can quickly generate a frame for my model. Okay, and in the next step I would like to show you that how you can make for yourself these user-defined dialogues. So I will start a new model and close this existing one. No, basically I can use this model too. So the main command for these user input dialogues are basically, if I go back to the wiki, the get user input commands, which you can find here at the input commands for parameters on our wiki page. Here you can find all of the available options what can be used on the dialogues, and if you click on any of the controls you can copy paste these codes and you can use it in your ConSteel model. But currently I want to show you on a quick example. For example, I will create a member and so it's basically just a simple member with an age 200 section, and let's say the parameters which are necessary for these members will be asked from the user on these dynamic dialogues. So I will type the get user input command, main command, and let's say I want to ask the user to give the height of this member. So what I'm going to use is the number option. At the number option we have to define two parameters. Let's start right with the second parameter, which is basically just a text which will be highlighted on this user defined dialog. So I can, for example, I will type that please give the height of the column, and the other parameter here is basically a variable definition. So if I type here the height, when ConSteel processes this command, it will create a variable, the height variable, which is basically the same like I would use in this way, and I would give a value for it. Okay, so if I run the code, as you can see, we will have this dialog with the text which I have typed here, and the text box where I can type any kind of numbers, and the value which I have typed here will be stored in the height variable. But currently I'm not using this height variable for anything, so I will go back to the to my script, and I will use this height variable here at the structural member command. Okay, and as you can see right now we have an error message. This error message basically is because right now the height variable is empty. It has no value in it because it will have its value after the user gave the value on the dynamic dialog. So what we have to do is to initialize the height variable at the beginning, for example, of your code. So let's give an initial value for this height variable just to get rid of this red disturbing error message. So let's say I will give a 100 value for it. Okay, and now in this way we could get rid of this error message, and if I rerun the whole script and, for example, write 5000 millimeters for the height of the column and click on the OK button, ConSteel will generate that column with that specified length. Let's say next we want to create a drop-down menu where the user can choose that what section should be used for this column. And for this, to create a drop-down menu, we will use another control. We will place another control on the dialog, which is the option control. On the wiki, you will find a complete description that how you can use this command, but I will show you in just a minute. So I will type option, this is the main command. It will also have two input parameters, and I will use the AND option, which will close the drop-down menu. So anything which is defined between the option and AND option will be listed in the drop-down menu on the dynamic dialog. So again, the second parameter of the option is just a text which will be represented on the dynamic dialog. So let's say, please choose the section of the column. The first parameter is again a variable which will be used to store the selected value of the drop-down menu, which will selected by the user, of course. So I will give the name section for this variable, and now you can see that the control is not properly filled, so we have to fill the drop-down menu with values. Again, we have two parameters. The second parameter is the name of the list element. So if I type, I don't know, HEA 300 S235, this will be the text what the user will be see inside the drop-down menu, and this will be the value behind it. Okay, let's give some more values to the drop-down menu. Okay, and as you can see, if I rerun the code, we now have a drop-down menu added to our custom dialog with those texts or list elements filled up with those elements which I have defined here. And if I would click, for example, HIE 320, the HIE space 320 value would be stored in the section variable, and I could use this section variable, for example, a load section command. Let's quickly do this. So instead of loading a section manually, let's say that we want to load the section variable, and again you can see that we have an error message that because the section variable right now does not contain any value inside it. So let's say at the initialization part of our script, at the beginning lines, we will give a value for this section variable. For example, this one. Okay. And at the create command, I will also use this section variable here. Okay, and one more new command, which is good to know, is the clear all command. What it will do, that it will erase your whole model at each running of your script. So if I will rerun the code again, first it will delete every member and every object from my model, and it will create the members again. Okay, so if I rerun the code, as you can see, because of the clear all command, ConSteel erased the existing member. And if I type the height of the column and choose a cross section for it, for example HIE 340, and click on the OK button, the section is generated according to this section. So if I select the member, you can see that the section is the proper one which I have selected from the list. Okay, and the next control which we can place on our custom dialog is a bit tricky, because it will, let's say we want to define that where do we want to place a member. So instead of giving the start coordinates directly or manually here at the script, we can ask the user to please select a point in the modeling area which can be used as an insertion point for your member. So for this we will use the point command, and quickly I will check that what are the necessary parameters which I have to define on our wiki page. It requires, yes, again two parameters. First is a simple text, please select a point for the insertion. And the other parameter is a variable definition. In case of this point command, it is not a simple variable, but it is an array. An array is a bit different than a variable because it can store more values as a list, basically. So because if you click on if you want to get start point coordinates x, y, and z coordinates from the user, it is 3 value, x, y, and z coordinates, and these values could be stored separately in individual variables, or it can stored in an array. So here if I say that, for example, this will be the coordinates array, this simple array will store all of the 3 coordinates, x, y, and z. Okay, and quickly let's see how this control on our custom panel, custom dialog looks like. As you can see, we have please select a point for the insertion and the selection button, and if I click on this button and click anywhere in the modeling area, it will collect x, y, and z coordinates into this text box. Okay, usage of this array is a bit tricky. It works a bit different like variables, because first we have to obtain a value of a variable from the array and store it. So what we will do is we will use the array get function, which of course listed at our wiki, and I will copy paste it into my code. So what this command do, you have to first tell that from which array do you want to obtain data. The array, the name of the array is of course the chords array. Again, at the next parameter, input parameter, you have to define that which of the which is the parameter, which is the coordinate that you want to obtain. So we have three coordinates x, y, and z. The x is the first element of the array, the y is the second element of the array, and the third is the third element of the array. But in case of arrays, the first element of an array is represented with a 0 index. So the 0 element represents the first member of the array. So the first will be the start x coordinate, and this is the name of the variable which will be used to store the x coordinates of the array. I will repeat this 3 times, and at the second we will obtain the y coordinates. So the second element of the list of the array will be the y coordinates, and the third, which is represented with the second index, will be the z coordinates. So right now we are successfully obtained every coordinates from the array, but again we have an error message because currently the array is empty because it's not defined by the user. So again we have to go back to the beginning of our code, and we have to define the values of the variable, give a starting value for the variable for the array, for the elements of the array. For this we can use the array set function, and the array set function, at the first parameter of the array set function we have to define that what is the name of the array. It will be the chords array, and at the 0 index, so the first element of the array will be 0. The second element will be again 0, and the third element will again be 0. Okay, and as you can see, we could get rid of these annoying error messages. This is called the initialization for the variables. Okay, and there is one more step with what we have to do, that we have to use these variables for the creation of our member. So at the creation of my structural member, I will use these coordinates for the start point coordinates. Okay. And if I rerun my code, the user will receive this dialog. He has to set the height of the column, the section of the column, and if he selects the insertion point, that point will be used for the member. So this is the start point, and well, the end point currently is the 0 values, so that will be used for the member. Okay, and one more thing that I want to show you is how you can ask the user to make decisions on the dialog, on this user-defined dialog. So for this, we will use the bool control, which is basically a true or false decision, and it more or less works the same as before. We will type bool. We will have two parameters. The second is just a text. Please decide if you want to, let's say, place a support on the start point. And at the first parameter of this bool option or this decision, we have to define a variable. Let's say this will be the decision. And this variable will be used to store the value of the decision of the user. So basically, we have placed a checkbox in the dialog, and if the user clicks on this checkbox, the value of the decision variable will be 1, and if the user does not check this checkbox, the value of the decision variable will be 0. And these variable and these values can be easily used in our code to create if statements, for example. And let's say if the user said that decision parameter is 1, so he wants to create a support on its member, the if statement will be active and the content of the if statement will be performed. Again, we have to initialize the value of the decision variable. So let's say the start value of this variable will be 0, and we could get rid of this error message. Again, ConSteel tells us that the if block is empty. So what we will do is that we will create a point support, and for the correct syntax rule I will go back to the wiki page, and inside of the create commands I will search for the point support function, and I will quickly copy paste the command for the point support creation. Okay, so what we have to do is we have to define the ID of the member on which we want to define or support. We have to define the type of the support. Let's say it should be a fixed support, for example, and we can use the coordinates of the start point of the member. Start Y and start Z. Okay. So currently, if the user clicks on this button, that decision that if he wants to place support or not, ConSteel will hopefully place a support on the member. We have to select the insertion point. We have to choose a section and height for the column. And if we click on the OK button, as you can see, a support is placed on the model. But if the user chooses not to place a support, it won't be placed. Okay, I clicked it. I think I clicked it again. Okay. So this is how you have to use these user input commands for creation of the dynamic dialogues. And basically, this was what I wanted to show you in this small demonstration and on this webinar. Thank you for your attention, and goodbye.